Hello, I'm Dr. Harper. This video is working an ABC inventory classification problem number 2. So let's bring up the problem. The annual usage and annual average inventory were obtained for each inventory in an inventory, for each item in an inventory, to examine the economically balanced nature of the inventory to determine if adjustments were needed for some SKU items. If the unit ordering cost is $90 per order, the unit carrying cost is 45 cents per dollar per year, then how many SKU items, average inventory levels, deviate either greater than or less than 50% of the EPP optimum average inventory level? Good question. So let's work this. First, let's take the problem, copy, Control C. Let's bring up Excel. And let's come down here a little ways and Control V and paste it. And so let's start working it here. And here we have it. Okay, so the first thing is, remember we had, let's see here, C sub O was, and C sub C, and then EPP. That's the first thing we're going to need. And so let's bring this back down here, and let's see here, let's bring this up a little bit. 90 and 45 cents per dollar per year. Okay. So this is going to be 90. This is 0.45. And so then the EPP is going to be C sub O over C sub C. Okay. Oh, it's nice and 200. So down here, let's just say the EPP equals this 200 up here. And then let's just copy this down, because we're going to use that for every single one. Okay, and there it is. Okay, let's see. Next, let's look at the optimal inventory. Whoops. Optimal inventory. Let's see here. The optimal inventory. Well, here we have to do some calculations here. Let's bring up the lecture notes. And coming down here, we know that the optimal, that's the optimal frequency. We know the average inventory is M over 2F, where M is the annual usage, over 2 times the frequency, where the frequency equals this. Okay, so therefore, if we do a little bit of algebra here, we can say, okay, fine, the M over 2F will equal M divided by 2 times the square root of, and up here it's going to be F, which is this, M divided by 2 times the number in the class. Well, in this case, the number in the class is just going to be 1, times the EPP. Well, we know what the EPP is. Okay, so that's going to equal M divided by 2 times the square root of, again we have M divided by 2, and we know that the EPP, well, let's just keep it in there, because we have the EPP already. We don't need to type it in. But let's see, we have just a 2 here times EPP. We can rearrange this. And notice this will be M over 2, and then it'll be, let's just go ahead and put this out, M times, well, 2's in the denominator, m's in the denominator, but then 2 times EPP will be in the numerator. But it'll be under the square root. So this is square root of 2 times EPP, divide by, and then we divide by the 2 times the square root of m. So putting it back together, and we have the numerator on the left, denominator on the right. Under the square root, the 2 is the denominator. Bringing that under the square root is 2 squared, and so that's 2 over 2 squared. It will just be over 2. EPP is in the numerator. It stays there. But then m is in the denominator. M is the numerator. Bringing that under that square, so m squared over m is just m. So that's just simply going to equal the square root of, the m is going to be in the numerator, times EPP, and then we're just going to divide that by 2. So just a little bit of algebra there. And so let's take this. We know that this is what we want. That equals this. Same thing. So the average inventory is going to be this expression right here. Let me just copy this. Bring this back down. Let's put it up here. Optimal inventory. I'll put it up here. And there it is. So let's do that. Okay, that's going to equal the square root of m, which is this m right here, EPP, which is this, divided by 2. That's really all it is. So it's not that hard. So let's just copy this down. And so there's our optimal inventory. Let's change this around here. Optimal inventory. There we go. Okay, now remember what we're asking here is how many SKUs, average inventory levels, deviate either greater than or less than 50% of the optimal. Well, probably the quickest or the easiest way to do that, and let's just take an index where the inventory of 1 divided by the inventory of 2. In other words, I'm going to take this and say let's say this is 1. The average annual inventory, that's the existing inventory. Let's divide that by the optimal inventory. And so that's going to be just an index. Well, if it's equal to it, it's a 1. And so if it's greater than that, it's going to be more than 1. If it's less than that, it's less than 1. But if it's more than 50% more than that, it's going to be more than 1.5. If it's less than 50%, it's less than 0.5. Okay? And so let's look at the percent deviation. Let's put it up here. Percent deviation. And that's simply going to be let's say, that's going to equal the absolute value of 1 minus that percentage. Okay, but that's going to be in a percentage. So let's look at this. Say, okay, let's see here. Well, I'm going to let this equal absolute value of 1 minus that. Now, when I subtract 1 minus that, what that's going to do is it's either going to be less in the absolute value. So whatever that is, if it's more than 0.5, it's going to be more than 50%. So let me just multiply that by 100 to get the actual percentage. Oh, this is more. So let's bring this down. Okay, now we can see the ones that are more, greater than, less than. So now let's say greater than 50%. Let's do an if statement. If this is greater than 50, then say yes. Otherwise, just leave it blank. And that's more than 50. And so we bring this down, all the way down, and you can see how many yeses pop up. And that's how we find. So now this type of problem is just really simple because you have the average inventory, you have your usage. This is pretty much given. if you know what your unit costs are, or you can determine an EPP from other methods, you can determine how much out of control each inventory item is in your inventory. And so these would be your flagged items, and those flagged SKUs is where you're going to go out and say, do we need to lower inventory, raise our inventory? And if we do, it's just going to start bringing the inventory costs down into some manageable range. Now, these aren't that much out of whack, but in practice, sometimes they are significantly out of control. Okay, and so that's this problem. That's all I have for this problem. I hope this helps. Thanks for watching. Take care.